Hello everybody, in this video we will see the electronic configuration of elements. To be able to understand the electronic configuration of elements, there is one important term and it is the orbitals. We can also call it atomic orbital. An atomic orbital is a region around the nucleus of space in which there is a high probability of finding an electron. So it is a probability. We also call it electron cloud because electrons move very fast. It is the region in space where there is 90% probability of finding an electron. If the center of an atom is here is the cloud, electron cloud that we can find an electron. There are four types of orbitals and they are S, P, D and F orbitals. We also need to know the shapes of orbitals. The S orbitals are spherically shaped as you see here. Here is the center of the atom, it is the nucleus of the atom, and so here is the region that has the probability of finding an electron there. This is the shape of a p orbital. There are three types of p orbitals and it differs their axis. Here is the z axis, here again is the center of the atom nucleus. We don't show the s orbital. If it was here it should be like this. So the other p orbital x-axis is like this, located like this, and the y-axis p orbitals are like this. Altogether they seem as in the figure like this. Here again is the nucleus of the atom. Again here is the shape of orbitals. You see this is the s, these are the 3p orbitals, and d orbitals like this. Here the center is again the nucleus of the atom, and there are 5 types of d orbitals and there are 7 f orbitals as you see here. These are the shape of them. You don't need to memorize their shapes, but you need to know how many orbitals does every type of orbitals have. S orbitals has one type of orbital, and there are 3 types of p orbital, 5 types of d orbital, and 7 types of f orbitals as you see here. These are the number of orbitals that each type of orbitals have. So s orbitals have only 1, and p has 3 orbitals, d has 5 orbitals, and fs has 7 orbitals inside. And every orbital can have a maximum of 2 electrons, so s orbitals can include 2 electrons maximum, and p orbitals can have 6 electrons. D orbitals, there are 5 orbitals, so multiply it with 2, it can have 10 electrons, and f orbitals can have 14 electrons inside. In electronic configurations, our aim is to place electrons of an element correctly. To do this, we need to know the energy levels. Here is the energy levels of an electronic configuration. You see the lowest energy is belong to 1s orbital, then 2s, then 2p. You can see here 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. So there is no uniform flow here. And we also need to know the Aufbau principle. Aufbau says that electrons occupy the orbitals of lowest energy first, so we need to know the lowest energy and the order of energy levels. And the order of energy levels is here: 1s, 2s, 2p, 3s, and 3p, 4s, 3d, 4p, 5s. It is like that. The easy way of memorizing the order of energy level is like this. You can use this. The song like S, S, P, S, P, S, the P, S. It goes like this. The P, S, F, the P, S, F, the P, S. You will not use all of them always, but this is an easy way. Think that we call everything twice. S, S, 2 times S, PS, PS 2 times, the PS, 2 times, F, the PS, F, the PS 2 times. So the other trick is the start S with 1, P with 2, and D's with 3, and F's with 4. So we first doing the S orbitals 1, 2, 3, 4, 5, 6, 7. So we don't need this because there are at most 7 energy levels. Then start P's with 2, 3, 4, 5, 6, and 7. Start D is with 3 here, D, 3, 4, 5, 6, and F with 4, 4F, 5F. So there are orbitals in order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. These are in order of energy levels: 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 5p. When we see a configuration like this, this bigger 2 means the energy level of the electrons, and the P is the energy sublevel, and here the upper subscript, the number of electrons. According to the Pauli principle, an atomic orbital may describe at most 2 electrons. So to occupy the same orbital, 2 electrons must have opposite spins. That is, the electron spins must be paired. We can explain this rule like this. The s orbitals have 1 orbital inside, and it can have 2 electrons at most, and we need to show the electrons with arrows upwards and downwards in opposite directions. P orbitals have 3 different orbitals inside, and the electrons can replace like this. And D orbitals have 5 type of orbitals, and F has 7 different orbitals inside. You see that S orbital can have 2 electrons at most, and P can have 6 electrons at most. D can have 10 electrons like this, and F can have 14 electrons at most. The last rule is the Hund's rule, and it states that single electrons with the same spin must occupy each equal energy orbital before additional electrons with opposite spins can occupy the same energy level orbitals. What this means is that when you start to fill the 2p orbitals, for example, you need to first fill orbitals like this with the same direction, then you can move to opposite directions. Think that if our configuration ends with 2p4, we can't fill the electrons like this. 1 2 3 4. This is not correct, but this one is 1 2 3 and then 4. This is the correct one. So this is what Hund's rule says. Here is some examples about the electronic configuration. What is the electronic configuration of oxygen? Oxygen has 8 atomic numbers and 8 electrons in neutral when it is neutral. So we first start to putting the orbitals, and what was it? S, S, P, S, P, S. We don't need more. Actually, this is more of what we need. Then we need to put the energy levels. S starts with 1 2 3. P starts with, for here, P starts with 2 and 3. So we know that S orbital can have a maximum of 2 electrons. So we need to complete 8. So 1s can have 2, 2s can have 2, and what is remaining? 8 minus 4. We need to put 4 more electrons. P orbital can have 6 electrons, but we don't have 6 electrons. We have 4 electrons, so we put 4 here. So we don't need these electrons. These are excess. The result is 1s2, 2s2, and 2p4. If the question asks us to show the orbital diagram, the orbital diagram for this configuration is 1 box for s, 1 box for 2s, and 3 box for p orbitals, and we put the electrons in order like this: 1s, 2s. Be careful, there are 4 electrons. Remember the Hund rule. We first put the electrons in same direction to all orbitals, all sub-energy levels, then the second ones, and the 4 electrons are put in this order. In the second question, the question is what is the electronic configuration of chromium 24, and show the orbital diagram. To do this, again we start with the orbitals: S, S, P, S, P, S. You need to do this for a while to get used, and the PS. This will be enough for us. We can go on with the PS, F2 PS, but this is enough. And start S with 1 2 3 4 5. Start P with 2 3 4, and start D with 3. Then we need to complete the 24 electrons, and this is 1s2, 2s2, 2p6. There are 10 electrons so far. 12, 18, 20. So we have 24 electrons, and 3d can have 4 electrons, and we don't need them. This is our electronic configuration. And start to fill the orbital diagram. This is our orbital diagram. For 1s it's like this. For 2p it's like this. 3s, 3p, 4s, and be careful, we have 4 electrons for the orbitals, and we are done. Chromium and copper has an exception for electronic configuration, and this is because Because half-filled orbitals are more stable, the one electron from this 4s goes to this blank orbital for 3D, and the new configuration is automatically 4s1 and 3d5. So we can show it that way: 1 2 3 4 5. This rule also is applied in copper. It ends with 4s2 3d9, but to be able to fulfill the last orbitals, not only half-filled or full-filled, I want to say, orbitals are more stable, and it is automatically 4s1 3d1 10. And in all other elements the rule is applied normally, and these are the exceptions. If you have further questions, you can ask me in the comments part, and that is all for this video. Bye.